Welcome back, guys. Welcome, guys. Yeah, basically what I was saying, guys, this is a contactor. It's called a contactor. It's a special switch used in electrical motor controls. The reason why I decided to bring this item here is because it's in demand in industrial use, very much in demand in industrial uses. And it's very important to know how it operates, why it is important to have it. So we just said this is a special switch in which we cannot ignore anywhere we use motors. So what I'll be doing, guys, I'll be illustrating to you how it's labeled, how we connect it, and tell you why it is very important. Join in. This is the second session. I was live again, but I think it was cut off. Remember, this is a workshop. We have to expect customers coming in now and then. So thank you for your patience, guys. Welcome back, everyone who had joined. I'm very sorry for that disconnection. I'm live here. So guys, please come on, hang on. We are live. It's gonna be cool. welcome all. Invite your friends, let them come. Everyone who is present, welcome, feel welcome. We are back in our topic, guys. This is called a contactor and it's rated in amperes. It is used in motor controls for switching on and off of motors. So there are several other gadgets like the stop button, start button that are used with this gadget, but I'll explain later how we actually connect these gadgets together with this gadget here. But for now, my main interest is to illustrate how it works and just give you a review of again why we need it. Thank you, Harun, for joining in. So we said this is called a contactor. It has the input side of it and it has the output side of it. So before connecting it, we actually tend to take these readings here. Thank you, Vikesha. We actually take the readings here because it is rated. Everything in electrical we said it's rated. So before connecting it, make sure you know the rating of that specific gadget. So we have said why we cannot connect a motor directly to power is because of the main reason being it's a very demanding or very high induction load. If you do that, it will actually consume a lot of power. That makes the cable you are connecting your motor with to start heating up or start burning up. Thank you, Betty, for joining my class. Um, then we've said it's not just connected like that. There is another special gadget here. This is one of the components that is used together with this. So what basically happens here is that before we take our load or before we actually connect our load, we apply this gadget to make sure we are safe on the side of consumption, that is the load. Thank you, Chief Frank, for joining in. So this contactor will actually have its mains coming in through the top part of it. It has actually labelings. That is, we have this is I don't know if it will correspond with your camera, but it's labeled T1 or 1T. Thank you, Odari Papa, for joining. It's labeled. Thank you, Nancy. Thank you, everyone, for joining. It's labeled 1T or T1. Then here we have 2, we have 3, 4, 5, 6. Then I know somebody is asking why we are not saying 7, 8. That is why I said it's very important when we are connecting these things to make sure we have the correct rating and correct termination. The reason why I have not said 7, 8 is because we have 6 major terminals: T1, T2, T3, T4, T5, T6. The major inputs, all the major power inputs in our system must be from up. This says we have number 1, number 3, and number 5 being our inputs. That shows if you have your 3-phase you need to connect, you just connect it from onto these 3 terminals. 1 T or T1, T3 and T5. On the lower side of this gadget, we have the output. Thank you everyone for joining in. Kate, everyone who is joining me, thank you very much. Don't get passed away by this lesson. So what I'm saying is we have the output on the lower side. When you have input here, fed here, that is three phase, red, yellow, blue phase. When this switch goes in like this, after the activation, now you will get this now connected together. You see? So thank you Alain for joining. So if you have power here and make this switch go on like this, the power will be outsourced from this point. So now this gadget is used to make sure that the power coming out from these 3 points here does not exceed our rating or the needed power of the motor. Thank you much Ariang, thank you Dasa for joining. Everyone is welcome in this page. Thank you very much. So after putting our power here and switching it, we need this gadget to make sure when there is any problem on the side of the load, that is the motor itself, it will automatically cut off power. That now calls for another complex, or not complex, but another hard or difficult connection that we have to apply in the control, because the control is actually the determiner of when this thing should go on or off. On like this, engaged, off, disengaged. So what we do guys, thank you very much everyone who has joined in. We connect this gadget on these terminals here, these three output terminals, so that when the power is coming out, you can see we have these pins. It actually passes through this component first before going to the cable heading to the load. So it will appear something like this after connection. I hope you can see my setup. So thank you Boaz for joining. So these pins here will actually enter these poles like this. Yeah, actually now you can see. Then we have on the lower side now where we are gonna connect our power out. Thank you Emma for joining. Our power out. So any power that is coming from this point will not exceed the trip current set on this knob here. So if you look carefully, here we have some gadgets that you can, we have a screen you can open like this, and you can see this knob here. This knob is used for tuning or adjusting how much current should this gadget allow to pass through these terminals. In case of any overcurrent, there is a mechanism inside here to trip. These terminals are connected in series so that when this one trips, it will cut off power going to the start control circuit and disable the coil. The coil is the one that engages this contactor here. So when we are not connecting A1 and A2 to 240 volts power, this thing will not engage. Like you can see we have The coil is rated. Remember, we have said everything must be rated in electrical. So we have this coil is rated 240 volts AC. So if we connect our 240 volts here, this thing will actually engage and go inside like this. This means it will have connected our power from supply to load. So this is how we use these gadgets together. So sorry guys, we connect them in such a way, then this should be actually where our control point starts. 95, 96 is normally closed. So when this circuit is engaged, this coil remains closed until a fault occurs or overload. That is when it will disconnect, and hence this thing, because it was engaged, it will jump out like this and cutting off the power, hence bringing safety. So that is why we use contactors instead of just normal switches when we are controlling motors. That is very important. So guys, um, you can also see here we have some coding. These are called wide range, you see, and they are compatible with different types of contactors. You find that some contactors have wider space between pin to pin. So what happens is that you can adjust. You see there is a notch here and a notch here. You can actually move these pins slightly, and that is the information that is coded here. Our only movable pins are pin number 1, this one, and pin number 2, this one, and you can see they are the only ones with notch. This one does not have a notch, so it's not movable, you cannot move. So this means you can actually adjust the space between these two according or depending to which contactor you are having. So this red button here is used for reset. When your machine has tripped or a fault has occurred, this thing remains off. This thing remains off, or the power here remains cut off until you push this button again to reset. To reset. So what you do, you just press it and release. That means when this knob here is set to auto, when it's set to auto, it will actually actuate that reset mechanism. Remember, it has manual and auto reset. So we have to make it automatic so that it will be automatically reset after you press this button here. So there is something very important with this switch here or this contactor. Reason is this switch can either act as manually held switch, that is with a local switch, or with a non-trippable switch. You can actually maintain this on by actually feeding 240 volts to these coils. I'll give a lesson of how to make this go in or actuate this switch. I'll make a video and give also a live lesson on that. So we have coil number 13 and coil number 14. This says you can actually use this coil to hold on this gadget or this switch without actually needing to press on the switch for so long. Thank you, Shara Oma. So what we do, we actually engage this switch number 14, number pins 14 and 13 in parallel, in parallel with the start button. That is the green switch number 3, 4. So you connect a parallel switch to number 13 and 14, then press that switch once, and this thing will stay locked inside like this until the power from 1314 is disengaged. That is why we use it to hold it, and we call it the hold on coil. So apart from that, guys, I have some special things. So this one, you can see here, it has a rated current, voltage, and also how much power should this thing carry. Of course, power is a factor of voltage and current, but they actually indicate it here. Thank you, Sally, for joining. So, what we do is actually follow up these instructions here before we even connect anything. What we actually look for is the current rating. All electrical gadgets have current rating, and hence this gadget here, it is rated up to what current it should carry, and that implies that your motor should not exceed what is indicated here. For example, this one is 25 amperes, IAH is 25 amperes here. So anything above 25 amperes should not be used with this contactor, or any motor exceeding 25 amperes should not be connected to this contactor. But with that said, guys, we also have the rating here for the coil. The coil is mostly 240 volts or 315, or 415 volts for three phase, but there are contactors of even 24 VAC. That means where we have faces or dashboards where hard operated dashboards, high voltages could be risky. So in most cases like this, we actually use contactors with coils actuation voltage 24 VAC. That is very important to note. You can check here, it has a label. Every contactor has a label here. So this will give you exactly how many volts you should apply to this coil. If you want to know the coil is okay, place your meter. You can take your meter and adjust to resistance mode. Make sure it's on. It will give you a high resistance. This is not one, it means high. So if I hang my meter there, I take my probe. Join my page, guys. Thank you for joining. If I take these two probes and I point at my coil, that is number 1 and number 2, like this, sorry for that mistake, guys. So if I connect like this at terminal A1 and point the other at terminal A2 here, the coil is giving me something. It is giving me resistance, not actually continuity, but it has resistance. So you can see that's pin A1 and A2 there. It's giving me resistance. It's giving me about 800, between 700 to 900 ohms. So that's a good coil. So if I apply 240 volts here, it will actually go in. It will actually engage this. Something else, I have something here, guys. This is also a contactor. This is also a contactor. And this being a contactor, we can see it has switches on it. A black, according to the manufacturer, is written on. It should actually be like this. It's written on, off, on, off. You can see. I can also see it has something like the knob we had here, and it has a small hole here written test. I want you guys to tell me what's the difference between this and this. That is functional difference. And you can see it has poles, three poles. Just to give you a hint, remember we said you need to have a stop button and a start button with this. Then, very important, it has coils 13, 14, but this one does not have coil 13, 14. But I can see terminal 1 up to terminal 6, main terminal. Thank you, it's Manu. Thank you to my for joining my page. Um, Actually, these are used for the same purpose, but they have a difference. I want you guys to give me a good explanation about it, and I will also be giving you my answer about it. So these ones are called contactors, and they are used in motors. We have done a review of all of this contactor here, but I have this. Let me know the difference and why is this one not having a coil that this one has. Um, Last time, guys, we had discussed about power generation, and I asked a question. I asked you guys to tell me, or in simplest words, to give me the definition of the word electricity or electrical power. Many people tend to confuse and say electrical power is a power that moves only in conductors or something like that. But let me give you what I think is right, guys. Electricity or electrical power is a kind of power or is power produced when a flow of electron happens. When a flow of electrons happen. This is not even a 10-word sentence. It's power that is produced when electron flow. So, or when there is flow of electrons. Why am I saying this? Let me justify this. I'm saying this because if you tell me electricity is produced when we rotate a magnet against a coil or something like that, yes, it could be true to some extent and it is very right. But we don't have magnets in solar panels. We don't. But actually, whatever happens is that when you move a coil past a magnet, electrons flow. That is where now the reasonings meet or the answers meet. In solar panels, we have flow of electrons when the solar cells are hit. When the solar cells are hit by light, we get flow of electrons. When we move a conductor past a magnet, it means we are actuating flow of electrons. So electricity is power produced when flow of electron occurs. So thank you guys for your trial. I'd like to also hear about my question today. I'll be giving you my answers tomorrow, if not tomorrow, on Monday. So thank you for this lesson. I'll also be presenting to you what we need to use so that we can have this thing operating like typically on the field, or to connect these gadgets so that it can practically run a motor. That is what I will be showing you very soon. So we said you can follow me on my pages, Hood Engineering Solutions on Facebook, Hood Engineering Solutions on YouTube, and here guys on the TikTok. You can also find me at Hood Engineering Solutions. Let me know if you like my content, my lessons. Remember, I have live classes that is on weekdays from Monday up to Friday, but we don't do it from Monday continuously to Friday. We have like 2 or 3 classes per week, but I'll try to improve depending on your recommendation, guys. So, thank you for joining my classes. This is a contactor. This is a contactor, both used for the same purpose, but they have a functional difference. That is how they function is different, but they are used for the same purpose. Tell me what's the difference. Tell me what's the exact name of this. I'll be giving you the exact correct answers maybe tomorrow or on Monday. Keep tuned. So invite your friends, let them know there is somewhere they can learn about electricity, live, like practical lessons. Here we don't actually forge things, we present them as the way they should be in the field and from a professional point of view. So guys, I have actually taken you through one important lesson that we are gonna cover in future, and maybe not very soon, not too far from now, but we are gonna cover it under machines and utilization. I'll take you deep on how motors operate, how we repair motors, how we actually determine what speed a motor can run or the RPMs of a motor. Remember, this is just one point of it, controls alone. Thank you guys. Thank you Faye for joining in. Unfortunately, you just found our class at the last minute, but thank you for your support. Your presence is very much considered of importance here. So, guys, I have actually taken your time. Thank you for dedicating it to me. I cannot actually assume or just ignore that effort. Thank you very much. We are going to have a few clips today about 2 3 tips on how to do things concerning electrical. But here we are. We are gonna be having live lessons as we have been doing the this ending week, and yeah, it has been great. So thanks so much. In the evening, I'll be making maybe a live appearance just to discuss something I feel you are worth knowing. So follow me on Facebook, like my page, like, comment, share everything. Then I'll be here in the evening to give you a hint of the topic I want us to discuss about. So thank you very much. Tell your friends to subscribe. Come in. Let's learn together. And please invite those who are interested, any engineering student or anyone who is willing to join the engineering field, let them know that we have a home here where they can get all this knowledge. Thank you, guys. See you in the evening. I love you all.